So see, I'm pushing this guy. Now, of course, if they get too pushed, I can push them into the tree. But that's just a matter of how arcade physics handles collisions. Welcome back to Arcade. I am Super Tommy, and in this video, we're going to look at Phaser 3, ECS, that's NAD component system, and arcade physics for collisions between dynamic bodies. Now, we've covered adding arcade physics to a Phaser 3 game using ECS, and we've covered using ECS with arcade physics static bodies. So you can go check out those two videos on the Arcade YouTube channel. That's youtube.com/arcadehq. That's OURCADEHQ. And while you're there, be sure to subscribe to the channel for more videos on using Phaser 3 in various ways, whether it's NAD component systems or NAD component system. I guess I meant to say is the component pattern, or ECS, or any other means of game development on the web. So be sure to subscribe to the channel, and if you've been enjoying our videos, do hit like on this video as well. It is the best way to support the channel, by liking our videos and subscribing. Okay, so we've covered adding arcade physics to a Phaser 3 game that is using ECS. That's bit ECS, that's the library that we're using. And then we did the static to dynamic. So this is our player moving tank that has a arcade physics body. You can see that red or purple outline around it. And our trees here are static bodies. And as you can see, we can collide with our static tree obstacles here. So what we want to do is bring back our CPU. So we added CPU tanks just randomly moving around in our 4-part ECS series that you can find on the Arcade YouTube channel. Hopefully I did spell arcade correctly last time. That's OURCADEHQ. That's youtube.com/arcadehq for that 4-part ECS series. Now here we're going to bring back our CPU tanks and make them use the arcade physics system. So let's make myself smaller. All right, so we commented out the CPU system just to get arcade physics working in here. Now let's just bring that back. Just bring that back. Bring that back. And here. Now, arcade physics, of course, has its limitations that you probably already know about, and you're going to run into the same problems here when we bring this back, that sometimes things will overlap with each other if they're just pushed into each other, or if they just start out on top of each other. So of course, there's also Matter.js that you can use in Phaser 3. And if you are interested in seeing how you can use Matter.js with ECS in Phaser 3, let us know in the comments below. Now back here, we are going to add, let's just do 10 CPU tanks for less chaos. Let's just do 5 for less chaos. So we're adding our tanks. Now our tanks are much like our player. Now if you recall, our player works with the arcade sprite system. It needed 4 components. That's the position, rotation, velocity, and arcade sprite component. So here it's very similar. We need all those 4 components as well, which we normally put in. Position, rotation, velocity, and we were doing the sprite component, but we don't actually need that. We want the arcade sprite component since our tanks are dynamic bodies. And so we want to come here, and it's going to randomly pick between those. So that's good, that's good, that's good. Now let's just, we do need to create our CPU system and make sure it updates. Let's just see what it does when we just do like an easy add back of all the things. Okay, so you see they don't collide, so they do collide with the trees. Let's just wait for that. Right, so this guy, they do try moving, as you can see that. This guy's going to try to move into the tree. And you know they're not going to. They'll start on the tree. That's just part of how arcade physics works. Let's just refresh. So you can get a better feel. Like you'll see no one is going to purposely run into the tree. Right, there you go. I think you kind of saw that. That guy stopped because it was stopped by the tree. If we don't do a random, you'll kind of sort of see once they're out of the tree, they're not going to run back into it, like right there. So that collision works simply because we already created our arcade static sprite system and made it collide with our our player, which is a normal arcade sprite. So that collision is already done. Those systems are already in place, so once you just add any entity with those components, it'll just work. That's the magic here of ECS. You can organize code and share logic very easily. Now, but what we actually want is for the player to also collide with these CPU tanks, which they're of course not right now. So to do that, it's actually very simple. We're gonna, just like here, of adding a sprite group and a static sprite group to adding a collider for those two groups, we can add a collider for the sprite group and the sprite group itself. So now all arcade physics sprites will collide with each other that are in that group. So see, I'm pushing this guy. Now, of course, if they get too pushed, I can push them into the tree. But that's just a matter of how arcade physics handles collisions. They can push me. So there we go. So there's the So this guy is still stuck. There we go. I can actually kind of better prove. Yeah. Okay. Go towards the tree. Yep, and it stops because it can't move since it collides with the tree. So all the collision is working as well as arcade physics. Phaser's arcade physics can handle it. And so there we go. That was literally that easy. Our CPU component, let's just go and review what it does and how come we had to make almost no code changes. And so let's go to our CPU system. So all our CPU system does. So it does this accumulated time. And just to note here, we did get a comment from a viewer, and thanks for that comment, that there is a slight bug here. We are setting this accumulated time to 0, but what we actually want to do for most accurate, greatest accuracy, let's say, is actually we don't want to set it to 0 as much as we want to subtract that interval time so that we don't lose time. So if you add dt and it goes over whatever time between actions, let's just say 2 seconds, then you set it to 0. So if it was like 2.05 or 2.1 and you set it to 0, now you've lost some time since you're starting again at 0. So you want to just subtract the time between intervals that you were thinking about, so that you would then now start at 0.05 seconds, or whatever the actual number is. But anyway, back to what we were saying. So this CPU system is very simple, and it does the only thing that the CPUs need to know, and which is which direction am I going next. And so because it does it very little, we didn't have to do any changes to this, because all the physics logic is in a different system, and the movement logic is in a different system. So that's our CPU system. And of course, our movement system already worked for the player, and because of that, it'll work for the CPU tanks as well. This is just how nice ECS can help you, or one nice way ECS can help you organize your code and let you just combine different functionalities by adding components together to different entities to produce different results and not have to repeat code in a bunch of places. Right? So this is more generic logic that can work no matter who's getting these components. And so then all we had to do was bring back our tanks and everything is working, because in our arcade sprite and arcade sprite static systems, we don't care who it is that has these 4 components or these 2 components, right? It doesn't matter who. As long as they have it, we're going to operate on them a certain way, in a fairly generic way, on what that system specifically does. In this case, it just sets values for the arcade sprites in Phaser 3. And so there we go. So that was very simple. That was adding collisions between dynamic arcade sprite bodies. Now, if you enjoyed this video, be sure to hit like, and again, subscribe to the Arcade YouTube channel for more videos on using Phaser 3 with ECS and all other means of making games.